Example 1 asks us to expand each of the following expressions. The first one that we have is x to the 1/2 plus 3y to the 1/2 quantity squared. Now, when you see something like this, you cannot just square the first and last term. Okay, you actually have to build the square. So think about what this would look like. So you have x to the 1/2, you got 3y to the 1/2, you have an x to the 1/2, and a 3y to the 1/2. So now you can go ahead and actually fill this in. Well, x to the 1/2 times x to the 1/2. When you multiply things that have the same base, you actually add their exponents. 1/2 plus 1/2 makes a whole, so you get x to the first. And then you have x to the 1/2 times 3y to the 1/2. Well, nothing has the same base here. You could actually combine the x to the 1/2 and the y to the 1/2 to make an x, y, both to the 1/2. Because since they have the same exponent, you can actually combine them that way, but that's not necessary here. So we're just going to rearrange this and call this 3x to the 1/2, y to the 1/2. This would be 3x to the 1/2, y to the 1/2 as well. And then finally, 3y to the 1/2 times 3y to the 1/2. 3 times 3 makes 9. The y to the 1/2 and the y to the 1/2 make y, so we get 9y. Now, when we put all this together, we have 1x. We have a 3x to the 1/2, y to the 1/2. We have another 3x to the 1/2, y to the 1/2. So we have 3x to the 1/2, y to the 1/2, which overall makes 6 of them. And then lastly, we have our 9y at the end. So the important thing to remember with a problem like this is just to stay organized and take it piece by piece. Don't make the rookie mistake of just squaring each term, and also don't forget about any coefficients that you have. The rules for indices and surds are kind of odd because of the way that exponents work. So just keep that in mind for when you are working through your problem. The next problem is a little different. It has us saying we have a to the 2/3 minus b to the 1/3. This is multiplied by a to the 4/3 plus a to the 2/3 b to the 1/3 plus b to the 2/3. And you're like, wow, this is kind of crazy. Well, this, instead of being a square, this is actually kind of a rectangle, right? It's not the same thing. So you could still do it the same way that we just did. Notice we're going to have a to the 2/3, and we're going to have, this is a negative b to the 1/3. So remember, pay attention to that. That's important. Then we have a to the 4/3, a to the 2/3, b to the 1/3, and b to the 2/3. Well, now we can go ahead and combine these. Well, a to the 2/3 and a to the 4/3. We add the exponents. 2/3 plus 4/3 makes 6/3. This actually makes a squared. And then we have a to the 4/3 times negative b to the 1/3. We'll move the negative out front. We can't combine these. They are not the same base or the same exponent, so we can't combine that. So we have a to the 2/3, and then a to the 2/3, b to the 1/3. So these can combine to make a to the 4/3, and b to the 1/3 that is left. And then we have a to the 2/3, b to the 1/3, times negative b to the 1/3. The negative would go up front. The a to the 2/3 would remain here. And then we would add the exponents for these, which would make b to the 2/3. And then lastly, we've got b to the 2/3 times a to the 2/3. So that's just going to be a to the 2/3, b to the 2/3. And then we have b to the 2/3. We have negative b to the 1/3. And that is going to make negative b overall, because we bring the negative out front. We have b to the 2/3, b to the 1/3. We add the exponents and we get that. So now let's see if we have anything of like term. We have a to the 4/3, b to the 1/3. We have a negative version of that. So these actually cancel out. We have an a to the 2/3, b to the 2/3, and a negative a to the 2/3, b to the 2/3, so those cancel. So we're actually just left with a squared minus b after all of that work. So as you can see, there's lots of little calculations going on, nothing major, just doing some simple addition with fractions, just making sure that you're organized, making sure that you know exactly what you're getting into before you start doing some calculations. Because the one thing you don't want to do is start off on the wrong foot, right? So just figure out a way to organize yourself. I like the boxes. They seem to keep people visually attached to the problem, and so they don't forget a step.